Hello students, welcome back to JCE Connect series of lectures. In previous lectures, we have been solving one design problem, that is a design of gusseted base, and we have gone through some of the steps, and in that we have been calculated the size of the base plate finally, and the size of the base plate we have obtained as 700 by 350 by 22 mm. The size of the base plate we obtained for the gusseted base. Now the next step, as I said earlier, the design of connections. So we need to do the design of connections. So in this particular lectures I'll be calculating the design of connections, how the design of connections or the number of bolts required for the connections, how to calculate, I'll be solving in this particular lectures. So here the design of connections, as you know, the first thing we need to calculate the bolt value here, because the load is being given, the load is acting on the column, and for that load how many number of bolts are required for the connections. So we need to calculate first the bolt value. Since ordinary bolt of property class 4.6 is given, so this is mentioned in the problem. If in place of this ordinary bolt, if HSFG bolts mentioned, you have to calculate the strength of the bolt based on the equation, that is the HSFG bolts equation given in the code. You refer code and take that equation and calculate the strength of HSFG bolts. That becomes the bolt value itself. Okay, here the ordinary bolts are mentioned here, so I'll take the ultimate strength of that bolt as a 400, because the 4.6 property class is mentioned here. So 400 will be the ultimate stress. Then the diameter of bolt is mentioned 20 mm. The diameter of hole becomes 22. Then calculate the minimum edge distance required and minimum pitch required as per the codal provisions as per IS 800/2007. Then 1.5 times of diameter of hole will be the minimum edge, and 2.5 times of the diameter of bolt will be the minimum pitch. So I'll get 35 and 50. So this is 35 and 50 I got. So provide that much edge distance and minimum pitch. Now let us calculate the bolt value. So as you know how to calculate the bolt value, the bolt value will be the minimum strength between the shearing and bearing. We have to calculate both the strength, that is strength in shearing and strength in bearing. And here in this particular case, the bolts will be double shear. So this is the arrangement of gusseted base. So when we provide a bolts here, if you provide a bolts here like this, when you provide a bolts here like this, so this bolt will be under double shear. Okay, so this will fail in a double shear for the gusseted base. So I'm taking here the bolts will be in a double shear, the strength of bolts in double shear. Okay, so I'll calculate first the strength in shear. So this is the formula, you all know this formula, how to calculate the bolt value. Fu divided by root of 3 into gamma mb nn anb plus ns asb. I'm assuming the bolt will fail in the threaded portion, and I have taken it as a 2 because I have assumed double shear, and the shank portion is 0 here. So this term vanishes. So finally I get the bolt strength in shearing, that is 90.54 kilonewton. Similarly calculate the bolt strength in bearing. This is the formula we know, and this formula is given in IS 800/2007, this formula, and in this formula KB value will be the least of these four, E divided by 3 DO, P divided by 3 DO minus 0.25. So calculate these all things, then the least of these least among these four you have to consider as a KB value, that you substitute here. And the thickness here you have to take the minimum of all thicknesses provided. The minimum means here the flange thickness is here, then the plate thickness is there, gusset plate thickness, angle plate thickness. So here the flange plate thickness is 11.6, and the plate provided is 12 mm, this is 16 mm, this is 15 mm. Among all the four, the least will be the 11.6. So that least thickness to be taken. Here I have taken as a flange thickness, that is the least 11.6, and the 20 mm dia, then the 410 is the ultimate stress of the plate. When you calculate, you will get the bearing strength, this one. And the bolt value will be what? The minimum of about 2. The least of about 2 will be the bolt value. So I got bolt value as 90.54 kilonewton. Then once we get the bolt value, it is very easy to calculate the number of bolts required because the load is given. The load coming on this column, as you know, the load coming on this column will be given, that is 1700 kilonewton. This is the factor load given. But in the gusseted base, when the load is given, so when these end of the column is machined and welded with the base plate, when it is perfectly machined and welded with the base plate, then for complete bearing on the base plate, so this will give the complete bearing on the base plate. So when the column is perfectly machined and welded with the base plate, this will give the complete bearing. And because of this, what happens? The 50% of the load, whatever the load is given, this is 1700 load is given, the 50% of this will go directly through bearing. When it is acting axially, the 50% of axial column load is assumed to be transferred to the base plate directly through bearing, and the remaining 50% will go through the connections given. So this is the assumptions you have to make. Means the whatever the load is acting on the column, the 50%, I'll repeating, the 50% of the load is passing through the bearing, and the remaining 50% will pass through the connections. The connections means it includes the through the gussets, through the plates, and through the angles, and through the stiffness it will pass. So 50% will go directly, and the 50% will go through the connections. Hence here given, assuming 50% of the load will pass directly and 50% of the load will pass through the connections. Hence, to calculate the number of bolts for the connections, we need to consider only 50% of the load. Then the number of bolts required, that is 50% of the given load divided by the bolt value. When you take the 50% of the load and calculate, you will get say 9.3, say 10 numbers, and these 10 number of bolts you need to provide on one side of the gusset. See, like this you will get, this is the picture you get, the gusset. Okay, so here look at this one, this is the column, and these two lengths were calculated already. This is the length of the column, sorry, length of the base plate, and this is width of the base plate. These two already we have got. The length we have obtained as a 700 mm and the width we have obtained as a 350 mm. Okay, then for the flange you need to provide the gussets like this. Okay, then the width of the gusset, this gusset width is equal to the width of the plate provided. Whatever the width of the plate is provided, that much length only the gusset to be provided here. Okay, for the gusset, the angles like this. Okay, now whatever the number of bolts you have got, 10 number of bolts, that 10 number of bolts to be provided on one side, then 10 plus 10, total number of bolts will required is 20, and whatever the 10 number of bolts you have calculated for, this is for one side. Okay, now you have to arrange the bolts. Okay, and this is the web cleat angle, nominal angle to be provided, and the nominal number of bolts to be provided here, 4 number of bolts. Okay, and since here the gusset plate is connected to the angles, and this angle is called as a gusset angle. Okay, this one. I hope you understood this figure. So now you have to draw this figure. Okay, so I got 10 number of bolts. So now you have to arrange the bolts like this. Okay, so draw this gusseted base. So this side I know 700, this side, then it will go like this side. Okay, so this side will be the B width, then 5 number of bolts. So what I do here, so from here I'll leave a 35 edge distance. 35 is the edge distance. Then I'll take a pitch of 50. I'll leave a 35, then I'll provide one bolt, then I'll take a one more pitch, then I'll provide one more bolt. Then you take one more edge distance from edge of the angle, then provide one bolt to the here, because only we have got 10 number of bolts. Okay, and this bolt will go along the width P. Okay, then this is 150. Then the total height of the gusset required, here you will understand this one. Okay, so here I have provided 2 number of bolts, 1 1 1 1 here. Okay, 1 2 3 4 5 6 7 8 9 10, total 10 number of bolts. So here I provided, and when you see, this will be the side view. When you look from this side, and this is a front view, elevation. This is elevation, this is side view. When you look from this side, you can see this pattern of the bolts. Okay, so here this one. When you see from this side, you can see this one. You can see this one. Okay, so here provide the bolts like this, and also for this also the bolts are provided connecting angle, one leg of angle, then the base plate, this one here it has shown, then the anchor bolts here on all the corners. Okay, so you can see here, see that for this leg the bolts are provided here, and here I provided one line of one row of bolt, then one here, one here, one here, one here. Okay, then anchor bolts here. Okay, then here, then this is on the side view, you can see only the angle height. Okay, so behind the angle the gusset plate is there. Okay, so to look aesthetically good, this gusset plate is cut at certain height. So after angle leg, so it is been cut taperly. Okay, then it looks good. Okay, so this is the connection of gusset plate to the column. So I hope you understood this one. Okay, so finally you have to draw the figure like this. Whatever the number of bolts you get, you have to provide on one side. Okay, if you get more number of bolts here, if suppose if you are getting a 16 number of bolts, 4 more bolts need to be provided, then you can provide 2 rows of bolts here. You can provide 2 rows of bolts. Okay, since I got only 10 number of bolts, so I arranged like this. I have provided a 6 number of bolts here, then 4 number of bolts here. Okay, then after this, if bearings suppose here, okay, in the problem, if SBCF soil is given, in this problem SBCF soil is not given, so no need to calculate the concrete pedestal size here. If SBCF soil is given, then you have to calculate the size of the concrete pedestal required. The size of the concrete pedestal required, again you know the procedure for that one. So just you assume like this, you take the plate, then you take the You take the size of the plate like this, then this is the concrete pedestal, then you assume the load is dispersing at an angle of 45 degree. This was the load coming. You assume then take one side of the uh, base plate. Okay, then this is the length of the concrete pedestal. Then you calculate the uh, working load, then take the self weight of the footing, then total load, then the area required, it is total load by SPCF soil, then you'll get a area, then assuming the square footing, sorry, the square base, then you'll get length equal to breadth, then you calculate what is the depth of pedestal required. So just you follow the steps given in earlier problem, and in earlier problem also I solved this type of concrete pedestal, how to design the concrete pedestal, how to calculate the dimensions for a concrete pedestal. Please go through the previous problem, you will understand. It's very simple. If SBCF soil is given, you assume the load is dispersing at an angle of 45 degree. Then for that 45 degree, you calculate what is the depth of pedestal required, because you will get the length and width of the concrete pedestal based on the working load, and you will, based on the SBCF soil, you will be getting the area required. Then that area, whatever the area required, we assume the square concrete pedestal to be provided, then we get length equal to breadth. Then for calculation of depth of pedestal, we assume the load to be dispersing at an angle of 45 degree. Okay, sorry, this is to be taken working load. I hope you understood this one. So so in next next design problem, I'll taking the load with moment. Okay, so load with moment, how to solve that problem. So please practice this problem once again, and this SBCF soil, again I'm repeating, SBCF soil is given. You just refer previous simple slab base plate problem. There I have solved the concrete pedestal. The same steps to be followed here in a gusseted base. Thank you.